Okay, the next one's not. It may be equally difficult, but it doesn't have as much work. Okay, because it's such a weird looking thing. You've got a natural log equal to a sine. Oh my gosh, that's the craziest looking equation ever. But let's just see. So we know that the derivative of a natural log is 1 over, and then so if I do that, so it's going to be 1 over, and when I copy, it's going to be the x times y. Now, but since that's not just x, and not even close to being just x, a chain rule is needed. So chain rule always happens in a numerator, even if whatever you're dealing with goes to a denominator. Your chain rule is in the numerator. So my chain rule again is going to be the same thing that we had on the last one. It's going to be first times the derivative of the second. Okay. Plus the second times the derivative of the first, and the derivative of the first is x. So there we go. Now, so there we go. So the only place we needed a dy dx was in the second half of the chain rule there, product rule. All right, and then the right-hand side, the derivative of sine x is cosine x, no chain rule needed. So that's nice. Now, okay, so if you're wanting to get dy dx by itself this time, it would be a little silly to distribute like we did on the last one. So I think the thing to do then is just go ahead and multiply both sides by x times y. So if I multiply both sides by x times y, I'll partially have the dy dx isolated. I'll have a little bit to do after that. All right, so that fraction is going to be gone. I'm multiplying both sides. Here, I'll show that. Multiplying both sides by x times y. And I'm going to do it over here also, noting that that needs to go up front so no one thinks that my x times y is going to be inside the cosine, which, and normally you wouldn't, but in this case, there's a lot going on here. So, all right, and then subtract y from both sides. All right, so I'll have x dy dx. Just got some algebra going on now. So x, y, cosine x, and then subtracting the y from both sides, and then divide by x. And I can divide by x all the way across or separately. I don't know how Jean leaves it. She might just write it as two terms. I don't know. But I think I'll just write it as the one and move on with my life. So and even though if I broke this apart as two fractions, that x would cancel on that first one, and then I'd have a minus y over x at the end, which seems a little sloppy to me. So I think we'll just leave it like that. Okay. And just out of curiosity, I want to look and see what she did. And I'll do it live here. I'll try to. Oh, there you go. There we are. Just see what she did. Now that is very interesting. Y times cosine x minus x. So she broke this apart right away. Yeah. Let's see. Y cosine x minus 1 over x. Y and then the cosine x. The same thing we have. So she did a little logarithm rule at the very beginning. I didn't do that. I just went with the chain rule. So just a little note here. If you wanted to, she rewrote this as the natural log of x plus the natural log of y. All right, and then went. So she rewrote that as that, and then just did and had chain rule on that one only. Well, it's the same because if you do, she factored out a y. Let me make sure. Yeah, factored out a y, and then the cosine x minus 1 over x. Yeah. Okay, so let me go back. Yeah, 1 over x there, cosine x there with this x canceling out. Yeah. So what you did. So if you go that route, then you still end up with this y factored out, and then rewrote these separately, right? So I have the y factored out, and then here the x's would cancel on that first fraction, and you'd have cosine x over x. It's all the same stuff. I mean, I actually think I like ours better, really, to be honest with you. And then minus with that y factored out, and there's no x to be found on that term. That's a 1, and then you got 1 over x. No, 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 no. That x canceled out. Yeah. So that if yeah, that x canceled out. So you just have cosine x. So cosine x there is the only thing left, and minus 1 over x there. If you went this other route, but seems about the same to me.